How's it going? I'm going to work out some of these problems from the book from section 5.5 for you. These U subs. I don't know that I ever named or referred to this technique as U subs, but the U substitutions. So yeah, I'm going to start with 271 and do them in that section because that's the section they didn't tell you what to make U. So I figured those are the little bit harder ones. So 271, if you want my honest opinion, I think 271 was a typo. I think that they meant this to be 1 minus x squared. You can do it using, the way it's written. But given where it is in the book, I'm not sure that they meant it to be that. I'd have to check the answer to see if it matches up. But you guys can do that. I'm going to do it as written because it's a little harder. This actually involves a little bit of a trick. I actually refer to this as this trick, I should say, as the Wu-Gauss method. There were two students when I took calculus in 1992. We had a problem just like this on our homework. There were 12 kids in my class. Everybody went home. We all came back to school the next day, and everybody couldn't do this problem. They were all like, we didn't know what to do. We couldn't figure this out. And there were two kids in our class named Daniel Wu and Ryan Goss who figured out how to do this problem. And so we dubbed it the Wu-Gauss technique. But the Wu-Gauss technique is, we're still going to do the U substitution. So I'm going to let U equal 1 minus x. And then du is just negative dx, because that negative there. And the problem that you run into is you don't know what to do with this extra x, because you have u to the 99th, but what do you do with that x? Well, the trick, where the Wu-Gauss trick is you take this and you solve this for x in terms of u. So I take that equation right there, u equal 1 minus x, and then I put x in terms of u. And we're good to go. So now I'm going to have x, which is 1 minus u, times u to the 99th power, and then negative du is dx. And so now I'm going to distribute this. So that's u to the 99th minus u to the 100th du. And so that'll be the opposite of u to the 100 over 100 minus u to the 101 over 101 plus chips. And then go back and resubstitute 1 minus x to the 100 over 100 minus 1 minus x to the 101 over 101 plus chips. So I'm not sure if that's the answer in the book or not in the back of the book, but that's how you do that problem as it's written. If you did it with what I think was the original problem, where this would have been 1 minus x squared, then it would have been much more routine. So I'm going to pause and erase the board in between each one of these so you don't have to watch me erase. Okay, here's problem 272. The integral of t times 1 minus t squared to the 10th. So here's our u, 1 minus t squared. Du is negative 2t dt. So du over negative 2 equals t dt. So there's t dt. So that will be u to the 10th du over negative 2. And that's how I get around the step, just to save some time. So I got negative 1/2 u to the 11 over 11. Whoopsies. So that's negative u to the 22. Sorry, u to the 11 over 22. And that's negative, go back and resubstitute, 1 minus t squared to the 11 over 22. Plus the chips. Okay, 273. 11x minus 7 to the negative 3. Here we go. Let u equal 11x minus 7. Du is 11 dx. So du over 11 equals dx. So this is just u to the negative 3 du over 11. Add 1 to the exponent, do our rule. So negative 3 plus 1 is negative 2. Divide by negative 2. So that's u to the negative 2 over negative 22, which becomes, going back and resub, putting in the starters, I'm not sure if I used that expression during third period yesterday. That's supposed to be a 22 there. I'm not sure if that looks like a 22 to you or not, but that's what it is. So there's number 273. Pretty straightforward. 274, so let u equal 7x minus 4. du is 7dx, so du over 7 is dx, so that's all I got there. So this is u to the 4th du over 7. So that's 1/7 u to the 5 over 4. Oh, u to the 5th over 5. That's u to the 5th over 35. And then if I go back and resubstitute, that's 7x minus 4 to the 5th power over 35 plus chips. And there we go. Okay, 275 has got some trig in it. So we've got the inner antiderivative of cosine cubed sine theta. So you might need to think of this, in case you don't see it right out the gate. You might need to think of this like this. That's cosine cubed. So that's your inside. So u is cosine theta. Du is negative sine theta d theta. And there we go, sine theta d theta. So this is u cubed, and then don't forget about this negative sign, negative du. So that's negative u to the 4th over 4. And then if I go back and resubstitute, that's negative cosine theta to the 4th over 4 plus chips. All right. All right, number 276, very similar to the last one we just did. So I'm going to let u equal sine of theta. Du is cosine of theta, d theta, which is right there. So this is nothing more than u to the 7th du after we make the substitution. And that's going to be u to the 8th over 8. And then just to save some room, I like to use the arrow here when I resubstitute. Sometimes I'll do that. That's going to be sine to the 8th theta over 8 plus the chips. Thank you very much. On to 277. Okay, 277. Very similar to the last two. The only difference now is we got another piece here. Got a pi in there that we've got to deal with. So I'm going to rewrite this like this, just to help you see it pop. So now u is going to equal cosine of pi t, and then du is going to be negative pi sine pi t dt. So du over negative pi is going to equal sine of pi t dt, which is right there in the problem. So now I've got ready u cubed du over negative pi, and I'll put that negative 1 over pi out there in front. So that's negative 1 over pi u to the 4th over 4, and then I go back and resubstitute. What was u? It was the cosine of pi t to the 4th over 4 times pi. And I guess I've got to stick a negative somewhere, so how about we just stick it there? And there you go. That was number, I think that was 278. I don't think I changed the number on the last one, but that was that one. All right, pause it up. Okay, so the last one was 277. This is 278. I would argue this is the toughest one of all the ones that you had for homework that last night. They give you a hint in the problem. We'll talk about that hint in just a second. But first of all, we need to probably talk about why the hint was even necessary. I can't let u equal cosine of x, because the derivative of cosine is sine, not sine squared. I can't let u equal sine of x, because the derivative of sine of x is cosine, not cosine cubed. So it's like I have an extra factor of cosine or sine depending on what I would have chose for u. So the way to do this, it's almost like we're going to borrow here. I'm going to write cosine cubed as cosine squared times cosine. Okay, now you think, well, why did you want to do that? Well, anytime you have an even power of sine or cosine, you can put it in terms of the other. So, for example, if I have a sine squared, I can put that in terms of cosine squared. If I have a cosine squared, I can put that in terms of sine squared by using the Pythagorean identity. So what I'm going to do here is I'm going to turn that cosine squared into 1 minus sine squared. And then I still have that extra cosine that I borrowed out. And now you think, oh, well, why is that helpful? Well, now I have everything in terms of sine, and then I have a factor of cosine sitting out here. That's going to be my du. All right, so here we go. Let's let u equal sine of x. Now, before I did that u equals sine of x, I could have distributed that if I wanted to. Doesn't matter. I can distribute it afterwards either also. Du is cosine of x dx, and look at that. That's what I wanted. So this ends up being u squared times 1 minus u squared du. And then I can distribute that u squared and make it pretty. U squared minus u to the 4th du. And now I can anti-differentiate. That's u cubed over 3 minus u to the 5 over 5. And then go back and resubstitute. That's going to be sine x cubed over 3 minus sine x to the 5th over 5. Okay? That one was probably the hardest one. Because first, you had to know that you had to borrow. I had to borrow a cosine out of cosine cubed, which was going to serve as my du when I let u equal sine. In fact, and I can only do it this way because if I can't borrow a sine out of this and let u equal cosine because I don't have enough of them. I would need an odd power of sine to do that. So that was problem 278. Again, probably one of the tougher ones. If you got that, if you figured out this on your own, kudos to you. That's a tough one. All right, here's the next one. 279. This one actually looks complicated, but it's not as complicated as the last one that we did. In fact, with this one, you could let u equal either one of these and it would work out. There's two different ways that you could do it, and I'm going to do them both ways to show you why they're the same. So how about we let u equal sine of t squared. So then du is going to be cosine of t squared times 2t dt. Don't forget the chain rule. Okay? So I have here cosine of t squared, and then there's a t dt. So that's going to go in for du over 2. Or du over 2 is going to go in for that. Just put the t out in front. So du over 2 is going to go in for this and that. So you basically are looking at u du over 2. All right? And then that's going to be 1/2 u squared over 2. So that's u to the 4th over 4, which if I go back and resubstitute, that's going to be sine of t squared to the 4th over 4 plus chips. Okay? So that's one way of doing it. Now I want to show you over here. We could have done this problem and we could have let u equal cosine of t squared. And du then is negative sine of t squared times 2t. So it's almost the exact same problem. So du over negative 2 equals sine of t squared times t. I forgot the dt here. So now it's u du over negative 2, right? So now I'm going to get negative 1/2 u to the squared over 2, which is u to the squared over 2. Oh my gosh. I just realized something over here. Somehow I squared u and wrote u to the 4th. This should be squared here, and that should be squared there. All right. So this is u to the squared over 4, but it's also negative. And then when I go back and resubstitute, it's negative cosine of t squared squared over 4 plus chips. Okay? So now, this answer right here and that answer right there somehow are equivalent. Somehow are equivalent. And I'll give you a hint of why they're equivalent. It's because of those Pythagorean identities. Because this, I can do it either way. Since I'm standing close to this one, I'll use this one. This sine squared right here could actually be written as 1 minus cosine squared of t squared over 4 plus chips. And then if I split this out, that's 1/4 minus cosine squared of t squared over 4 plus chips. And look at this. Now these are equivalent because that 1/4 can get just stuck into that bag of chips there and become that bag of chips. So pretty clever, huh? It's not very often you can do a problem 2 different ways and get 2 answers that look very different, but it turns out they're equivalent because they only differ by a constant. So that's 279, a lot of fun. Okay, so 280, almost the exact same problem as 279, okay? Except you got t cubed and t squared, but it's going to end up being the same problem in terms of u, or very similar problem in terms of u. Okay, so again, this one I could do 2 different ways. I'm only going to do it one way. You might want to try doing it the other way just for fun. So I'm going to let u equal sine of t cubed. So du is cosine of t cubed times 3t squared because of the chain rule. So there's cosine of t cubed, t squared dt, t squared, cosine, there it all is. I got that 3 that I got to take care of. So I'll put du over 3 equals all that. So now I end up with basically u du over 3. So it ends up being just an integral of u, just like the last one did. Except now we have a 3 instead of a, I think we had a 2 last time. So 1/3 u squared over 2. So that's u squared over 6. And then I go back and resubstitute. That's sine of t cubed to the 6th over 6 plus the chips. Okay, now you can write that sine 6 of t cubed, or you can write it as a whole quantity. It's up to you. All right, next one and last one. All right, and last one, for now at least. I'm going to let u equal x squared minus 3. Du is 2x dx. Just have x dx there. If you don't see this, it might help to write it like this to make it pop. That's how you write the original problem. So du over 2 equals x dx. That's what's du over 2 is going in for x dx. So this is 1 over u squared du over 2. Okay, I like to pull those constants out of there. They get in the way otherwise, in my opinion. You don't have to pull them out of there, though. So I'm going to rewrite this u squared as u to the negative 2, just in case we need to review on how to anti-differentiate that. It's helpful when it's written with a negative exponent. So we add 1 to the exponent, that's negative 1. Divide by that, so that's u to the negative 1 over negative 1, which is going to end up being negative 1 over 2 u, which is going to end up being -1 over, go back and resubstitute, 2 times x squared minus 3, plus the cheeks. So that's those problems. Thanks for watching. Have a great day. Work on the Delta Math assignment that's online. Spun some u substitutions and a couple other trig derivatives and antiderivatives. So see you soon.